Welcome to today's KM World webinar, brought to you by LucidWorks. I'm Mary D. Ojala, Editor-in-Chief at KM World Magazine, and I will be the host for today's broadcast. Our presentation today is titled Governing Enterprise Knowledge in the AI Era, Enhancing Relevance with LLMs and RAG. Before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session, so if you have a question during the presentation, just type it into the question box provided and click on the submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response to it within a few days. Plus, all viewers will be entered to win a $100 Amazon gift card just for viewing today's webinar. And now to introduce our speakers for today. Phil Ryan, VP Strategy and Innovation, LucidWorks. Eric Redman, Senior Director, Data Science and Analytics, LucidWorks. And now let me pass the event over to Eric Redman, Senior Director, Data Science and Analytics, LucidWorks. Go ahead, Eric.
Thank you, Mary D. Welcome, everyone. I think I'll simplify my title here and say I'm a product manager. I'm a product manager with a focus on AI and search, and I'm really interested in how those two things intersect and make each other work better. Phil, how about you give a quick intro?
Sure. So as VP of Strategy and Innovation, what I do is I lead our field engineering team. And in that role, I've had a chance to work on a bunch of different Gen AI implementations over the course of the past year and a half or so. So that's sort of the basis for what we'll be talking about today. So Eric and I kind of live in this world, right? The intersection of search and AI. And for a while at LucidWorks, a number of years actually, we've been using a variety of ML capabilities to make search work for our clients, to make search work better. And we're finding that Gen AI has been a perfect fit for some of the specific challenges that our customers traditionally face, that in the search space, many customers face. And so we've been able to integrate Gen AI into our solutions, and we'll talk about that today. And this grounding that we have in search and discovery as a company has proved invaluable. And a theme that we'll talk about today is you can't really have a good Gen AI experience without good information retrieval, without good orchestration capabilities. Those are key enablers. And so that's been working out very well for us. Let's talk about Gen AI specifically in the context of KM. We've all seen some version of the top half of this slide probably a million times, right? I don't need to reiterate the value of KM or the cost of not finding information, the impact on employees or customers or the bottom line. But writ large, the goal is basically to shorten the journey between the searcher and the information, right? And Gen AI is proving an excellent accelerator in that space. So we're talking about now the possibility of presenting not just a list of documents, but actual answers, timely and real time. Being able to take advantage of the increased semantic awareness with Gen AI so that we can more effectively infer the meaning of a query. Taking advantage of contextual awareness that allows us to not just have a traditional query response, but actually enable conversations and go beyond NLP or natural language processing to actually be able to interrogate interactively the data. And then on the indexing side, just the capabilities of offline data enrichment are myriad. And this has previously been more or less exclusively the domain of humans. And we're now moving beyond that with some of these tools. Eric, maybe you can take us down a level and tell us about some of the trends we're seeing in this space.
Yeah, you bet. And I think it'll link really well to the topic you were just touching on there, and that is Gen AI is not necessarily only useful or valuable during the the query interaction. So I think we all know about this GPU scarcity problem. And the large language models, we're working towards smaller and smaller models. But today, we're still at a point where you do really require GPU to get reasonable response time. With that scarcity, most of us are looking for ways to drive for more efficiency from the large language models. So how can we make them smaller and perform very close to the same level after shrinking them essentially in some ways? So maybe you've heard about quantization or pruning or knowledge distillation or mixture of experts. All of those things lead to the number of parameters or the size of the parameters each parameter takes up being reduced so that we can run on fewer GPUs and smaller types of GPUs. So that GPU scarcity, don't love it, but it has driven a lot of innovation over the last year in this area. Another thing I want to touch on here is there is more scrutiny now than I would say than, say, 18 months ago or even a year ago. Much more scrutiny of the Gen AI fit for purpose and what's the business value. Yeah, Phil and I both have received a lot of requests over the past year. Just we have to get Gen AI in somehow. We're being asked to do that. And now, thankfully, we've moved to, we see an opportunity. Let's look and see if Gen AI can help us there. Also, risk. So it's not just what is the potential value, but what's the risk of applying Gen AI in a certain use case to your business and to your users. Also, just note that the EU Council did pass the AI Act recently, and that if you go read the act, it's very readable. It's human language, unlike some laws. And you'll see a great focus on identifying the levels of risk involved in a particular use case for Gen AI. So we all need to be thinking about that. Phil, you touched on this recognition of retrieval relevance as a critical component. And I think we'll touch on this in a later slide, but one of the things Phil and I have both seen is much more focus on starting there. How can I improve recall and relevance? And we'll talk about ways to accomplish that. And the reason for that is that Gen AI, you're not going to have an easy time getting success out of Gen AI unless you can ground it in relevant documents that you trust for the model to generate its answer from. And then I think we'll talk a little bit about the deal with large and complex documents. This has always been the case since we started working with semantic type search. How do you dig into the meaning and multiple meanings that can be found across a complex document? And this is, again, very important in Gen AI use cases. Then we'll talk a little bit about model orchestration. Okay, let's go on to the next slide. Phil, tell us about this experience that we've seen, and it's mostly your team interacting with our clients over the past year.
Yeah, so these are just some examples of the work we've been doing in a variety of sectors. I won't go into this at the detail level, but I did want to pull out a couple of points here. First of all, you'll notice that neural hybrid search is on every row. And I don't want to belabor the point, but it is an important one that really, without effective retrieval capability, and neural hybrid search specifically, a combination of using lexical capabilities that have traditionally been employed with retrieval with semantic vector capabilities and integrating those to basically get the best of both worlds to optimize retrieval. So that has been a pervasive component of every implementation that we've done. The other thing that I want to call out here in general is just the KPI column, right? In choosing our use cases and focusing where we apply the opportunities, ensuring that we have in mind what KPIs or metrics we're going to use, how we expect to move the needle, and set expectations with stakeholders and with users around what that will look like. Maybe I'll call out a couple of rows here too. There's a couple of interesting things. Just the hospitality one. So what we're doing there is we're using embeddings models in conjunction with traditional NER or named entity recognition to match customers with desired property features, right? So they go to the properties that have the capabilities or the amenities or the features that they're looking for. And that's working well, but there are gaps with those capabilities, right? So embeddings, as opposed to traditional NER, can be more flexible. We can have some semantic variation in terms of how users ask for a particular thing in a natural language search. But sometimes that flexibility can lead us astray. And so in this case, what we're using Gen AI to do is provide some offline refinement of what we're able to match, right? So we can have the LLM identify new terms customers are using for traditional features, and then we can map them to canonical values in the data. We can also identify issues, right? So I talked about that flexibility taking us down the wrong path. Maybe the embeddings model thought that spa meant jacuzzi, when in this context, what the customer was talking about is they wanted a place they could lay down and have somebody put cucumber slices on their eyes, right? So identifying the variation in semantic intent or query intent based on context is something that the LLM is much more effective at than a. And then also identifying gaps in the data, right? So whether or not the property has information about this particular feature, the information that can be extracted is here's what our customers are actually interested in at scale, and maybe we should be tracking those features in our properties as well. So surfacing that content to content owners as appropriate has been very effective.
Phil, this is an interesting point. So you're talking about doing this type of analysis after the fact, or I think what you mean is not during query time. So
exactly. Right.
Perhaps batch analysis. And I guess the implication is that you'll take advantage of that later, and the way the query is processed improves over time.
Yeah, that's exactly right. So as the Gen AI portion of this solution identifies those things that I was talking about, that information then is either rolled back automatically into the traditional NER model, or it's rolled into the training data that's used for the embeddings model, or potentially surfaced to a human for action. But yeah, that's exactly the point. As we move forward, what didn't work yesterday can work next week because we have had this learning happening offline.
Yeah, I like that. It's a really cool example of, okay, I can't afford to spend 3 seconds during every query to figure this out with a generative model, but I can do it offline and then get the value from that next time. I like it.
Exactly. And being able to do that at scale. I want to mention one more thing in that B2B space before we move on. So there's some interesting things happening there too, and it sort of is keeping with this theme of offline validation, right? So one of the challenges, and it's a pretty pervasive challenge in our space, right, is just the uncertainty of whether or not we're addressing query intent effectively. So actually being able to understand how well are we answering these questions from a semantic perspective, and particularly how well are we mapping the query intent to customer data. We've got a particular set of data that we want to render in response to query intent. How well are we doing that job? And this approach uses, again, this offline investigation by the LLM. It actually uses a combination of embeddings models and Gen AI to map the query intent to the customer data. And that gives us two things. First of all, it can give us access real time to the LLMs level of inference, contextual awareness, uh, and be able to we can just by caching these queries, we can apply those real time. So address a substantial amount of query traffic just by saying, hey, here's what the LLM decided offline this particular recurrent query actually needs. Now we're going to give this to customers real time. The other thing that this does, which is potentially even more exciting, is it allows us to generate a test suite. So anybody who has worked with golden sets or validation, regression testing type information knows that there's a lot of heavy lifting associated with creating a golden set, defining the correct answers. And what we're doing here is we're actually allowing the LLM, or using the LLM to come up with that golden set that'll allow us to then quantitatively evaluate other relevance changes that we want to make, whether that's just potentially tweaking weights or trying out a new model, or potentially some other mechanism in the pipeline that we want to evaluate whether or not that will be effective.
Yeah.
So excited stuff.
Yeah. So we often think about, are we looking at implicit signals, actions taken by the user? What is their behavior after we present a response? And explicit signals, where we just ask for feedback and try to get that thumbs up, thumbs down response. But the way you're talking about this, there's almost a third category now, and it's sort of a synthetic explicit feedback by a large language model. Yeah, really interesting to track where this takes us. Let me describe this slide here. So Gen AI path to success. Don't take that too literally. So I don't mean this to be you define your use case, then you select a model type, then you integrate data sources. Of course, there's a lot of iteration going on here. So this is just more to show that it's a lot more than find the best Gen AI model for your use case, and away you go. So we'll have a slide for each one of these topics or cells that you see here, and dig in a little bit. All right. Balancing value and risk. I touched on this a couple slides back, but this idea of starting with a use case with high information friction, that phrase, information friction, kind of comes from, yeah, it comes from a physical idea about how much resource you're using to process information in an information system, a big computer system. It's an old idea. And here I'm using it to talk more about, I'm borrowing it, if you will, to talk more about what is the information friction for the human interacting with the system. So you could think of that as like cognitive load. How long does it take? How many documents does the searcher have to investigate? So on and so forth. So they start to build up the sense of friction trying to get to their goal. So that's what I mean by that, Phil. So next idea here, consider the implications of incorrect answers. So there's a risk there. What will an employee or a client agent, what will they do with the answer if it's incorrect? Will they make an important decision without checking references? And there's a couple of ways we have to deal with those things, but of course, one is make it very clear when the searcher is receiving an answer that comes from an LLM. People say now that comes from AI. That's kind of a general phrase. And also think about in your use case, what can we do to pick a use case where the impact of working with those responses is not as high risk? And that kind of goes back to that EU AI Act that was passed, and they do a very good job. I really like the way they wrote it, and they talk about will this use of AI have an impact on a person's life, for example? Is it going to impact their ability to get a job or get a loan, something like that? Those are very high-risk use cases from the perspective of the user, the person using the response, or someone else is using the response to make decisions about them. And I already mentioned this, just make sure that users are always aware when they're talking to an AI. We should incorporate citations and paths to trusted resources. Very important to try to create through the UX and through policy this idea that, just as you wouldn't, well, hopefully you wouldn't look at a Wikipedia page and take that as fact, you will follow the references and check those resources when the decision you're making could have an impact on others or on your business. And then experiment early. Phil, I know this is something that you've worked with a lot, and that is, we have a use case. We think it's a great fit for Gen AI. Do we actually have a model that performs in the particular use case area, meaning the type of language that people use when they're doing that kind of knowledge work, and what is the corpus involved?
Yeah, that's an excellent point. We often we think of these implementations. If you break them up into buckets, it is useful sometimes to think about the formulation stage, and then the proof of concept stage, and then the scale/implementation stage. Right? That was a little bit simplistic, but to this point of experimenting early, it's in the formulation stage that you really want to get a sense of the capabilities of Gen AI in general, given the kind of data and the idea that you have that you want to present to it, but specific models as well. And starting early with that, here's the set of data, here's the questions that I want to ask. Is this even a realistic use case? Is this really possible? Doing that early on is not only going to help you validate from a binary sense whether or not you should go down this path, but it could also provide some key insights about, hey, I didn't realize that we would potentially also be able to get this information. So it's a really important part of defining a use case.
Right. And the last point here, of course, measurement is key. So it can be tempting to move fast and introduce a generative model into a UX, but if you can't measure it, you're not going to know just by sort of anecdotal evidence that it's going to bring value to you. Okay, let's go on to the next slide here. So the idea of a richer, more contextually aware experience. We're looking here. We came from that flow slide that I showed earlier, and we have this one nice little cell that said select model type. And Phil, what are we trying to show here? I guess it's not as simple as that.
Yeah. So, Gen AI in general, obviously, there's a lot of buzz around it, right? And there's often a lot of pressure on tech leaders to implement it, to take advantage of it. And in some cases, there's even this question of like, well, do we still need everything else? Do we still need the old traditional search infrastructures and so on? Yeah. And the point here is that with Gen AI, we have this dramatically expanded tool set, but it is still a tool set. You don't throw everything at your new Gen AI model and figure that one size fits all. It's easy to get excited about the shiniest new tool and then lose sight of the fact that there's a lot of elements in this system, and you don't need Gen AI for every piece. Sometimes you can get there with a simple embeddings model, or even just some simple rules or heuristics. So whether we're looking at the portion of the system that's like query routing or implementing guardrails or specific types of guardrails or document summarization, there's a tool set here, and some of the traditional tools are also appropriate. The cost and the speed of these choices, or they vary by orders of magnitude, right? So this is an important consideration. What we want to do is we want to find, just as a matter of principle, the fastest, cheapest, and least intrusive way to meet the need for that particular element. And then even when we're talking in the content, go ahead, Eric. Do you have a question?
I was just remembering a year ago, Phil, that when I actually calculated for a particular use case the cost of using Gen AI to solve the issue, it's like, wait a minute, this is going to cost $1 every time we do it. Yeah, right.
Yeah, absolutely. And then that's a great point, because in the context of Gen AI itself, right, there's a wide disparity of costs in that space as well. So whether you're looking at, say, on the OpenAI side, if you're looking at using 3.5 or 4 or 4.0, all of those have different cost structures, right, or costs. And then the open source models that are available, right, then your costs are a little bit different, but there are still costs associated with that, and they're typically driven by token. So I guess the other point here is not to get married to a particular model. The model that wins and works best today is not the one that'll be winning tomorrow. And so having some flexibility and the ability to, instead of building around a capability or a particular model, be able to anticipate that that model is going to change. And the other corollary to that really is that because this space is moving so fast, there may be things that you need to work around based on the capabilities of a given model that are going to be obviated with the next iteration, right, or with somebody else's model. So you could build an infrastructure around being able to handle like JSON formulation, for instance, and then you get models that can do that automatically without any burden. So the broader point is flexibility is important. Think in terms of or anticipation of the fact that these things are not static. And the complete solution is going to rely on a combination of semantic vector search and Gen AI and heuristics.
Yeah. And
so a lot
certainly
of
costs. I was just going to say, Phil, that certainly costs are coming down, and I don't want people to think that we are obsessed only with cost, because if that interaction costs $1, but it brings value much greater than that, okay, then it's worth it if there's not another way to accomplish it. All right, ready for the next slide here. Yeah. So disparate data sources. So we know from experience, and I think it's probably intuitive, that as you put a Gen AI model to work to help with use cases like question answering and summarization and retrieval-augmented generation, you're going to be hopefully pulling in a disparate set of data sources. And I say hopefully because we're asking Gen AI at the core to help us so that the searcher, the user, doesn't have to hunt around across all those different data sources. So the point I want to make here is that those disparate data sources have a lot of different characteristics. And it could be that the quality of the data or the consistency, from one document to the next, there may be a lot of variability. That's a real opportunity, again, offline, for Gen AI to help mitigate those differences so that at query time, at search time, you get a more consistent integration of those sources, and you don't have that bias of this data source has better, let's say, abstracts, and therefore it dominates in the results. We want to try to get the right documents, not the one with the best abstract. So large and complex documents, I know that is near and dear to your heart, Phil. It's something you've wrestled with a lot this year.
Yeah, it is. There's so when we talk about large documents, we're typically talking or thinking in terms of chunking. We've all heard probably ad nauseum about the various approaches to chunking, and they vary from strict size limits and sentence counts to uh, utilizing markup to provide basically infer some contextual cues from the markup itself and determine what makes like a semantically cohesive chunk. And then, of course, semantic chunking itself, right? So we found that the LLM is typically not going to do a very good job if you just give it a big chunk of text and ask for chunk boundaries. But there are ways to use embeddings so that you essentially create a rolling list or rolling grouping of sentences with embeddings associated with those, and then you can evaluate when the embeddings have significant departures. That can be a cue as to whether when you've got a semantic chunk. There's also another approach that we've used in this space that we have found very effective, and it's sort of semantic light. Um, it's useful in a variety of contexts, but it can be particularly effective where you've got very semantically jumbled content. So back to the disparate data sources and data quality point that you were making, Eric. If you've got like a Slack thread or a comment forum, there's a very wide disparity in the utility of a given comment and its semantic value, and whether or not it actually can be pulled together into something that actually makes sense and is reusable and of value to someone coming after. And we found that using the LLM to extract FAQs from data like that, uh, essentially around the topic at hand, basically saying, give us a list based on this Slack thread of questions and the corresponding answers. It kind of gives the LLM a shot at deriving the key points from a conversation up front. Again, this is offline work. And then at query time, then that becomes the source for your retrieval-augmented generation. So it's been an effective approach to that.
It's a type of chunking, but yeah, a totally different approach.
Yeah, exactly.
And you were talking about Slack threads, and it reminds me of, thankfully, we don't see it too often, but it's not uncommon to see a thread hijacked. And it's
Right.
this approach that you're talking about would not be tripped up by that, because it would dig out that information there. And also, I wanted to clarify, I don't think you're saying that it's finding questions and answers in the documents or Slack thread.
Correct.
It's generating them, right?
Yeah, great call out. Yeah. So you've got an assertion in a Slack thread. Somebody asks a question potentially, or maybe doesn't ask a question, right? There's no question in the thread, but there is an assertion then, and the LLM can look at that assertion and construct an FAQ, a question and an answer combination from that assertion. Good point.
Cool. Yeah.
Eric, do you want to talk a little bit about a variety of things that we're not just talking about documents here?
Well, or another person might say, well, we are, right? That a query can be considered as a document, or a signal can be a document. And so that's the final point here. And Phil, you've touched a couple of times on the value and lower costs we can take from analyzing signals offline. Well, that's a lot easier to do if you are treating those signals and the queries that are part of them as full-fledged citizens of this corpus of different data sets or documents. So yeah, that's the point I want to make there is don't forget about those queries and signals and the opportunity for Gen AI to give us insights about those. All right, let's go to the next one here. So This slide, I'm just showing this leaderboard as, you have to have an image of something. I'm showing the leaderboard, but I do have a point here, and that is you're not going to be able to find success very often by just choosing a use case and going to a leaderboard. So what's the latest thing that I can afford to run? You're probably going to be running, as we said before, an ensemble of various different models. And so I want to talk about here about managing trust and security. You're dealing with all these different models potentially, and that may mean different partners if you are going to work with commercial models like some of the ones you see listed here. And then, of course, you will very likely have a variety of data sources that you want the model to dig out information about documents there. And so there's a, I don't want to say new, but pretty new, if we're looking back years, this idea of an entity within your organization called the AI Council. I have that word client there because I was thinking from the LucidWorks perspective. And the AI Council is very focused. So think of, we're all familiar with, you have an InfoSec team and you need to gather evidence and so on to support your case at this new thing you're trying to do. You will still be paying attention to protecting information. Well, with the AI Council, it's like, how are you using AI? What models, what partners, and so on? And are we sure that we can still uphold those same governance requirements about protecting the information, protect information of our clients, protect our own proprietary information, protect the information of the people using the system? And so you're putting trust in your counsel to do all that due diligence. So think about what they're protecting, and sometimes it can feel like, oh no, the AI counsel. Just remember, it's there for a reason, and it's very valuable. So more models, more partners, more data sources. You have all this data coming in from our trusted data sources. Hopefully you wouldn't include a data source that you don't trust all the documents in that data source. And we use that. We don't just ask the model without grounding it in the data sources that we trust. So I think we'll talk a little bit about concepts like retrieval-augmented generation, but the idea here is that you need to have guardrails around your data, like what are the data sources that you're using to do this grounding that I'm talking about. So you're prompting the large language model to produce responses based on the documents that you deliver to it. And references. It's so important to provide references to the documents that were used to generate this response so that your user, the searcher, can follow those references. Yeah.
Maybe I'll add a quick point about guardrails in general. And just quickly, the idea of guardrails, it's more than just, we all know about hallucinations and the danger of that. And it's more than just ensuring that we're not giving wrong answers. We also need to be thinking about the context, and the right answer in the wrong context can sometimes be just as damaging or potentially even more damaging, right? So if you have potentially provide information about a competitor, right, that's not drawn from your source data, but part of the intrinsic knowledge of the model, or maybe, not safe for work questions that you get answers from in kind, or maybe correct answers to a policy that's no longer in place, correct answers about a policy that's no longer in place. Those are also things that you need to guard against.
Yeah, good point. Yeah, and I think that ties into quite a bit in with this idea of the relevance of documents that you retrieve to interact with this large language model. That it's just more important than ever. So we also have this concern about should the searcher be able to see all of the documents in your corpus? And very often the answer is, for most people, no. They shouldn't have access to every bit of knowledge that your organization has. And so this is an old concept, this idea of security trimming. So, access control lists, we know who this user is. They can see this document. They cannot see that other document. Well, that needs to flow through when you start using generative AI, because, we talked about this approach, often called retrieval-augmented generation, where we query a trusted data source, and then we send a few, the first 5 or the first 3 documents that are most relevant to Gen AI and say, respond to this question, base your answer on the information in these documents. Well, even though the user is not seeing those documents in that back-end processing in this retrieval-augmented generation, the response might include information from them. It should, right? That's its job. And so we have to remember to security trim the documents before we send them, any part of them, in a prompt to a large language model. So that's at query time. The other thing to think about here is that you may decide to fine tune a large language model. Sometimes you hear instruction tuning. And in instruction tuning, essentially you're giving example instructions and good responses following that. So there again, you're going to have to be careful if you're using documents as part of generating the training data for this tuning, fine-tuning, instruction tuning. Now the security trimming is a little different issue, right? Because you don't have a user. You only know that you intend to use this model in a certain use case, and probably many different roles of users will be using it. So it could be that you have to trim out anything that isn't available to every user who might be using the LLM in that use case. All right, let's go on to the next one. Cost. I know we said, Phil, it's not all about cost, but cost is sure important, and there's a lot of factors.
Yeah. So it starts with cost per inference, right? So whether we're using an embedding model or a Gen AI model or something on the lexical side, right? The cost obviously varies dramatically across those, and really just understanding whether that's token based or request based, what it is costing us every time we ask those questions is really the starting point. But then moving past that into, whether we're talking about prompt or response tokens, the cost parameters differ there. But it's also just about how you structure your solution. So how many times will an LLM need to evaluate either the initial data or the response data? Will there be some kind of LLM verification that you're using? So there can be dramatic differences in how you go about or how many tokens you actually ultimately expend for a question, depending on how you structured it. One thing that's interesting is often we're finding ourselves, Eric talked about signal and queried data, and often we find ourselves evaluating long lists of very small token values, right, like queries. And the token multiplier can be pretty dramatic if you have to provide a prompt, a potentially extensive one, for every one of those. So being aware that we want to use a batching approach for that is an effective cost management mechanism, right? So obviously, the larger your batch, the more load there is, cognitive load on the LLM. So there's trade-offs that you have to be aware of. but being aware of batching as an approach and providing the LLM a prompt that is structured around a set of instructions per query can be really effective. And the other thing in this space is just, caching, right? These are expensive queries, or they can be. So anything you can cache, whether that's actual queries, questions and answers, or subsets of queries or query treatments, can save us money.
Yeah.
And then from a query routing perspective, I mean, there's a variety of options for handling a given query, right? We don't have to go to the Gen AI model for every interaction, right? So we can potentially, in some cases, for some questions or types of questions, we can get away with an embeddings model or a hybrid search. And maybe we can send it to our set of cached Q&A. Or even in the context of Gen AI, maybe we can use a less sophisticated, cheaper model for this type of question. But when it's this type of question, we need to use something more sophisticated. And we can do offline assessment using the LLM of the query traffic and identify the markers that can help with that routing.
Yeah, that's really cool. And I just want to call out here, Phil, that I think I mentioned this a couple of minutes ago, but it can sound like we're trying to avoid using Gen AI because it's too expensive. And that's not the case. It's just that we're trying, again, to balance cost and business value, or value that we take from its implementation. So I love the query routing idea because it's kind of doing that automatic. Well, it has to learn, but we're asking it to help us choose the interactions where there's value in using Gen AI. Yeah. Cool. So measurement. We talked a lot earlier about signals, implicit signals, explicit signals. What's different about the way we need to think about this is that Gen AI changes the journey. It hopefully removes some interactions from the journey that a knowledge worker or searcher takes, right? Because there will be hopefully many cases where they ask a question, something like that, and they get a response. And in fact, that's it. That's what they needed. So we don't have a ton of explicit signals now to go follow along and kind of deduce what was going on there. But we can also ask for explicit feedback. And maybe there's this idea, I don't think we have enough experience yet, the whole community, but maybe explicit signals our users will be more likely, they'll feel more motivated to react with an explicit signal, thumbs up, thumbs down, or some rating or something, if they buy into that, hey, this thing is actually getting better and I want to participate in that. But okay, it's good to ask for explicit feedback, but recognize the inherent bias, because we know that some things will trigger people to be more likely to provide that feedback, like they hated the answer, And so you wouldn't want to use explicit feedback alone. You still want implicit feedback, and it's just going to be a different approach to finding that implicit feedback, such as, what didn't happen after this search. So Phil, we have this point here, Gen AI is a measurement mechanism. And can you dig into that? It's not obvious right by its title.
Sure. So like you called out earlier, there's kind of a new category that's available to us now in terms of measurement, right? And that's basically using the LLM for some evaluation of the experience after the fact. So, or potentially in the context of like a reflection experience. Reflection is where we sort of let the LLM check its own homework before providing its answer. So there's a mechanism that is available there. We can also go through the history. You talked about how we captured different information, right? So now tracking the question that was asked, the answer that was provided, the documents that were retrieved, and the documents that were cited, maybe some chat context. But in the context of all of that, we can provide that to the LLM offline, and we can have the LLM evaluate or score itself against some rubric that we provide, right? And that'll generate a body of good responses and bad responses, and we can do different things with those, right? The bad can maybe suggest maybe some prompt re-engineering is necessary or some data retrieval changes. The good can then potentially prove a body of things that we can use for regression testing to evaluate new models. Essentially, any place that you have a human in the loop traditionally, LLM in the loop is an option. So a lot of possibilities.
Yeah, I kind of want to end this slide with the idea that measurement is hard. We have to think about new approaches now, but it is so worth it. And Phil, I recall listening in on some of your interactions with a client where it took a lot of work to be able to measure improvement or measure the performance of two different approaches. And maybe your client or you start to wonder, is this really worth it after you're having the fourth meeting about how to accomplish it? You come out the other side and it is worth it. Yeah, for sure.
Absolutely.
Okay, I think that is our final slide here.
And now we can go to questions and answers. So
Yay.
thanks to both of you. And I must say, though, I was really taken by one phrase you used earlier, which I am going to steal from you, semantically jumbled. I'm very fond of that. I can think of all kinds of uses for that phrase. Thank you for that. Now let me actually get to real questions here. Let me start with this one, and I'll throw this one to Phil. What specific benefits can enhanced tagging and categorization through AI bring to enterprise knowledge management? And then the second part of that question is, how can companies implement these improvements effectively?
Okay, cool. So, well, I guess anybody who's worked in the enterprise search space in particular knows how awful data is sometimes, right? Messy data is just a fact of that. So
semantically jumbled, right?
Yes.
And worse.
A search developer or a search PO, I mean, it's the bane of our lives, right? So, but the thing is, getting data right, especially across an enterprise, is so hard and it's expensive and you're never done. And I think a key takeaway here is that Gen AI can really be a game changer in this space, right? So whether you're talking about actually classifying against a taxonomy that you've got that, is traditionally the ubiquity of the tags for our taxonomy across an enterprise corpus is often so haphazard, and it can often cause more harm than good because it's not complete, or just content tagging or tag normalization, right? Where you've got, 4 different ways to say the same thing. We can send the LLM through the corpus and actually normalize and clean that up. And we can do that at scale in a way that has never been available to us before. So that's the opportunity. In terms of the second part of the question, how to do that, I mean, that could be a long answer, right? One thing I'll say is that LLMs tend not to do great with really long lists of tags or deep taxonomies. So using some mechanism to either, like, whether it's a multi-pass approach or potentially something we've had luck with, is using embeddings to sort of get a model into the right ballpark. And so, is this an engineering document or an HR document or a financial document? Once we have sort of that ballpark of potential tags or areas of the taxonomy, we can then use the LLM to say, okay, yeah, of this list of 15 that you gave me instead of 150, these are the 2 that are correct, right? So that's an opportunity there. And then I guess also just in terms of classification in general, don't forget about the point Eric made earlier about query history, right? You can you can apply Gen AI to your query traffic and classify or draw inferences about query types and query mix and different
Yeah.
success markers, that kind of thing.
Yeah. Yeah. Okay. I've got another one here. I'll throw this one to Eric since Phil did the last one. How does summarization by LLMs lead to actionable insights and better decision making within organizations? I think we're all looking for
Well,
actionable insights.
actionable insights. Yeah. Love the phrase. And when the user, so here's one way they help. When the user gets a good response, let's say from our generative model, but it is a case where they're making an important decision, they want to check the references.
Mm-hmm.
Now they need to dive into each of the first however many documents, the cited, the reference documents used in the answer. In one approach that can sort of reduce how often the user has to do that is to have a summary, and we're talking about a summary for each of the first N documents, let's say the first 5 or so, that is pertinent to the question. So give a summary from the part of the document that's pertinent to the question being asked, it's pertinent to the response. Mm-hmm. And that can absolutely streamline that journey or that interaction story there. Yeah. I'll give one more. Another is summarization can be topical. And a search analyst or the person organizing the corpus can pose particular topics or questions that should be answered and ask the system during data ingest to provide summaries relevant to that topic. So if in a certain area of knowledge, you want to be sure that there's a short description or summary on how this document relates to a particular subject area, that can be very useful.
Okay. And you recommend during ingest as opposed to some other time?
Well, the example I just gave can be done during ingest, and I would recommend that. Okay. During query time, summarizing those documents pertinent to the question, making sure the summary essentially explains, why are you showing me this document relevant to my question and the response from the model. Mm-hmm. That has to be done at query time or show up in subsequent similar questions. The thing Phil was talking about, you could do the how does this document relate type summaries later in batch.
Okay, right, gotcha. Okay, good. Well, that is all the time we have for questions today, and we apologize that we were unable to get to all of your questions. But as I stated earlier, all questions will be answered via email. And I would like to thank our speakers today, Phil Ryan, VP Strategy and Innovation, LucidWorks, Eric Redman, Senior Director, Data Science and Analytics, LucidWorks. If you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. Plus, you will receive an email with the URL to view the webinar once the archive is posted. If you would like a PDF of the deck, go to the handout section once the archive is live. And just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on July 31st. We will reach out via email if you are selected as this month's winner. Thank you again for joining us.